This conference will now be recorded.
Hello, dear friends. How are you? All well? So, today we will be moving ahead with a theory-based topic. I think I should call it rote learning type of topic. So, it's quite rewarding in terms of marks, school boards के लिए as well as competition के लिए. So, the Guru Mantra is the more time you are going to read it, the more beneficial you people are going to be. For this, the first book is going to be your NCERT. Remember all questions and the in-text, the back exercises, examples from NCERT. Right? Chalo ji. The D and F block element. If you see the periodic table from group number 3 and period number 4 starts the D block. This is considered as first transition series. It involves filling of 3D subshell. Yttrium to cadmium is considered as a second transition series, 39 to 48. It involves filling of 4D subshell. And the third transition series, hafnium to mercury, the 72 to 80. Remember, lanthanum comes here, 57. So that is considered as the third transition series, which involved 5D. You can say this is going to be the fourth transition series, but it is not at all important in the sense it is all man-made element. But yes, I have found a question many number of times, minimum 2-3 times. So I remember 104 element is known as Rutherfordium. So basically, we will be concentrating upon D block में 3D, 4D, 5D transition series, respectively called as first, second, third transition series. Then we will be hitting the F block element, the rare earth metals. So they start from, you call it lanthanides, but actually lanthanide is going to be the D block. So this is going to involve the filling of 4F subshell. Again, actinium, we call it actinide, but actinium follows in the D block. And after that, it is going to be 5F series, the actinides are going to be classified. So one by one, let's focus on D block and then we will focus on the F block. Agar mere se pucho, you must remember first transition, which you already have. You have done it many number of times in the atomic number, the coordination, compounds, and all. You have done it. Second and third, you have an option, but do not forget the placement of platinum, gold, mercury, right? Silver, cadmium. These are few elements which are very important. Tungsten 74, it has the highest melting point of all the elements. So just have an idea, and there is no option other than revisiting again and again. On a lighter vein, one of the most important element around you, symbolical hai, so that is going to be the most important element around you, the most important element. You can see in your cars, scooter, fans, buildings, anywhere you just bridges, you just put a look, you will be finding iron. चलिए शुरू करते हैं. So transition elements, the D block element. By definition, these have partially filled D subshell, partially D1 से लेके D9 in their elementary form, iron, right? Maybe chromium, or in their commonly oxidation state, iron plus, silver plus, etc. याद रखेगा this point. Their general configuration is last subshell, you call it the last shell, and penultimate, जिसको आप second last कहते हैं, 1 to 10. Copper, chromium, silver, gold-like element have one electron in the S subshell because of the anomalous configurations. Therefore, If you see, according to the definition, zinc, cadmium, mercury, यहाँ पे पड़े होते हैं बेटे, zinc, cadmium, mercury. It is 4s2, 3d10. This is बच्चों 5s2, 4d10, and this is 6s2 and the 5d10. अगर आप जिंक को देखो, कैडमियम को देखो, मरकरी को देखो, the common oxidation state of zinc is +2, so it will be having configuration of d10, right? It will be having cadmium +2 में exist करता है, no other oxidation state has been reported, so this is going to be the 4d10 बच्चों, the 4d10, and this mercury exists in +1, so this is going to have 6s1 5d10, and mercury also exists in +2, so that is going to be the 5d10. You will notice that zinc, cadmium, mercury has no, right, half filled, partially filled d orbital the configuration, either in their elemental form or any of their the ionic form. Therefore, ideally, the zinc, cadmium, mercury are not transition element because they do not have partly filled d subshell in their elementary zinc, cadmium, mercury, or any of their commonly occurring state Zn+2, cadmium +2, mercury +1, etc. But they are still classified as D block element because of their quite similar properties with D block element. This is going to be आपका एक NCERT का question बनने वाला है. Right? I think I have already discussed this thing. There are 4 different transition series. तो इसको जैसे Rutherfordium को we call it practically very less important even from the technical point of view because radioactive है. Who is going to allow you to go nearer to these elements? Neither your parents nor your teachers. They will not allow you to go near to them unless and until you are working in such a laboratory which has invested a huge amount in your protective clothes. That is very, very costly. Chale, so you remember the off-bow principle. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p बच्चों, 5s, 4d, and 5p, and so on. 6s, 4f, 5d, 6p. This is a sequence जिसमें मैंने बोला है 5f, 6d, 7p. The electrons will be filled. If you focus here, आपने इलेक्ट्रॉन किस में पहले डाला था 4s और बाद में किस में डाला था 3d. So which is going to have higher energy 3d and which is going to have lower energy 4s. So that is the reason कि जब आपने कैल्शियम की कॉन्फ़िगरेशन लिखी थी बेटे, so you wrote argon 18, right? यहाँ पे पूरा हो जाता था argon 18, and after that argon 18 you put an electron in 4s2. The moment आप 20 एटॉमिक नंबर से कैल्शियम से 21st यहाँ फॉरवर्ड जाते हैं, this order becomes ulta. The 3d will be becoming lower in energy and 4s2 will become higher in energy. That is the reason, if you people remember, अगर आपने इलेक्ट्रॉन रिमूव करने थे तो इलेक्ट्रॉन रिमूव आपने हमेशा हाईएस्ट प्रिंसिपल शेल में से किए थे, right? So after atomic number 20, this is going to happen because of greater penetration tendency of 4s towards nucleus than 3d up to atomic number 20. But after calcium, there's a sharp decrease in energy of 3d and its energy becomes lower than the 4s. So that is the 4s will be filled later and 3d will be filled. Remember. Also, as the nuclear charge increases, from scandium to zinc. 3d electron shield the 4s electron from the nucleus. Therefore, when electrons are to be removed from these atoms, the electrons will go from highest principal shell rather than the penultimate. याद करने की जरूरत ही नहीं है. You just follow the OFO principle for filling, and for removal, highest principal shell से electron निकालो. This is what you have been taught earlier also, right? In short, 4s3d पहले, 4s3d बाद में. Similarly, नीचे वाली रो में it is 4s 4d, 5s and 4d. 4d is more energy. पहले आपने 5s भरना है, but जब आपने इलेक्ट्रॉन निकालने हैं, it becomes like this. And similarly, why to memorize all this? Simple rule should be memorized. Filling of electron, OFO principle, removal of electron, highest principal shell. So that is going to save you from just memorizing unnecessary data, which I do not want. Righto. Let's move ahead and now see what I'm going to teach you. See, similarly, lanthanide and actinide are classified as transition element D block. As energy of 4f5d, 6s lies very closely, and one electron goes to 5d rather than 4f orbital. See, अभी जो करवाया था, अगर आपने यहाँ पे इलेक्ट्रॉन डालना है, you should be following what? 6s to 4f, फिर 5d डलेगा ना, you should be adding electron to 4f. But the drama happened. The lithium की जो expected configuration है, I'm sorry, lanthanum की गलत बोल गया, sorry, that is 4f1, but actually it is going to be this. Why? Because the d orbital and f orbital, this lie closer to nucleus. Closer to nucleus में what is going to happen? The attraction will be more. Attraction में क्या होगा? The energy is going to be lesser. So that is going to happen. Please remember that. Whereas in all other 4f are stabilized relative to 5d, an electron goes to 4f and hence are called at 4f. थोड़े समय में इसको fine tune करूंगा when I'm going to hit the f block. I will be telling you more exceptions there. Approximately 4 exception f block में lanthanides में आएंगे. We will be doing it in detail with it. Please do not forget. Moral of the story: the lanthanum is a D block. Ditto similarly, the actinium, it is expected to be this. अरे अभी तो कराया. This is expected to be 7s to 5f1 आना चाहिए था, right? But because of greater penetration of d orbital towards the nucleus, electron rather than going to f goes to this. This is expected, and this is, my dear friends, what the actual configuration is there, right? Therefore, I'm going to add actinium here. Every word I'm telling you here is important. Hence, lanthanum and actinium are D block elements rather than the F block elements. Shall Now, the next concept is coming. I hope everybody remember, when you move downward in the periodic table, you can consider here, you can consider here. What happens? The size goes on increasing. The size goes on increasing. That will happen here also. Important. So, as we move from first to second to third transition series, first point, radii in a particular series, decreases with increase in z. अगर हम इस तरफ साइज रखते हैं और इस तरफ z रखते हैं, एटॉमिक नंबर, दिस तरफ साइज, तो क्या कह रहा है? रेडियाई इन अ पर्टिकुलर सीरीज decreases, right? So it will go like this. ठीक, continued. एक minute. Yes, now we are here. See, but this decrease becomes small midway. Small midway, you will see this is practically going to be constant supply. And at the end of each period, there is going to be slight increase which is going to be formed. It will be this. Do you understand? क्या कहना चाह रहा हूं? There are going to be three dramatic things happening. As Z increases, पहले size decreases, midway it becomes practically constant, and at the end it increases. डाटा याद नहीं करना, ये ग्राफ को मन में रखना है. 164, 147, and so no, it will be averaged. बीच में deviations आती, 135, 129, 137. ट्रेंड देखो, it is decreasing. ट्रेंड देखो, प्रैक्टिकली बहुत कम डिक्रीज हो रहा है, कांस्टेंट सा रहा है. ट्रेंड it increases. 180, 160, 134 decreases, practically remaining constant. I'm saying not constant, increases lesser. कहां से 180 से 136 पे पहुंच गए, and after that it is showing an increase. Same drama is happening here, bede. You can see the trend. So notice this. We will be explaining why this is going to happen. Right? चलो जी चलते हैं. We are explaining that thing. With increase in atomic number, electrons are filled in n-1d subshell. You remember p block में भी किया था, d subshell की जो shielding होती है, that is poor. Therefore, if यहाँ पे radius या size बोल देते हैं, if this is there, as you are putting electron in the d subshell, what is happening? न्यूक्लियस को भी तो आप एक प्रोटॉन दे रहे हो, शील्डिंग बढ़ नहीं रही, तो न्यूक्लियस की तरफ अट्रैक्शन बढ़ रही है. Therefore, the size goes on decreasing there like this. The d orbital shieldless because of diffuse shape. Hence, the effect of increase in Z is more dominant than increase in shielding. Therefore, outermost electrons are strongly attracted to a nucleus, resulting into, my dear friends, decrease in size. This is A. Understood? A matlab the size is decreasing. Let's move ahead. In the middle of the series, right? Shielding and increase in Z perfectly balanced. देखा, it is D1, D2, D3, D4, D5. The electrons are filled what? Singly. So orbitals में repulsion तो है नहीं, there is only one electron. So this dramatic is being shown. अब mid में पहुंच जाते हैं. Now let's reach the mid. Right? In mid, what happen is the increase in Z perfectly balance, right? The shielding and increase in Z is perfectly balanced in the sense the size remains constant. He's talking about B point. अब इलेक्ट्रॉन क्या हो गए, भरने शुरू हो गए. So there is a tussle between Z की attractive power and shielding की repulsive power. And towards the end of each series, the electron-electron repulsion predominates. The effect of increase in Z, hence size increases. Now देखो, each orbital is being doubly filled. So what will happen? The pairing energy, the repulsion between electron is going to come into picture. And that will result into, my dear friends, the size increasing. Dobara, it is going to show an increase. I'm calling it as what? C bol diya. That is a trend video I wanted to explain you here. One concept. Do you understand why this is going to be the trend? You might ask in an objective form or something. Now, See, one more trick. See, 164 to 180, 147 to 160, 135 to 1 less. Let us draw one more thing. This black color is going to represent the first transition series. The black color. The black, the first transition series. Now, let's change the color of the pen, right? This is going to represent the second transition series. Second transition series देखो size बढ़ रहा है ना, 129, 137, 154. So this is going to be something like this. Now let's see the third transition series, the third one, right? The third transition series, the purple wala. The third transition series, notice करो 181, 87 थोड़ा सा माफ कर देते हैं ट्रेंड्स बनाने के लिए. 160, 158, 146, 146, 39, 36, 37, 34, 35, 34, 37, 38, 44, 154. What is that? The second and third transition series, dear, is practically having similar size. Do you understand? These are having practical similar size. Let us answer this. Why this is going to be expected? What is the reason for this? The reason for this is अब F block आने शुरू हो जाएंगे. The 4S, 3D and 4P, 5S, 4D, 5P. Now 6S, this is the first transition series, this is the second, and that is the third transition series. The 5D and 6P. Before you fill the 5D, एक जनाब छुपे रुस्तम 4F बैठे. 4F की shielding is even poor. So what is going to happen? Shielding poor है, size उसने बढ़ना ही नहीं देना, nuclear attraction बढ़ा रहा है. So where this was being increased, this increase is nullified, cancelled because of this F shielding, right? So 4D or 5D में size practically remain constant. I repeat, why does the third transition series element, the 5D, have practically similar size as compared to second transition series 4D वाले जिनमें fill होते हैं? The answer is, before filling the third transition series 5D subshell, the 4F subshell is being filled. Full stop. पैरा तोड़ के बताना. The 4F subshell has even diffused shape. Therefore, its shielding is going to be very, very poor. As a result, as 4F electrons are being filled, the Z effective nucleus key direction goes on increasing. The outer electrons are pulled towards the nucleus, resulting into decrease in size. This is the reason that why 4D second and 5D wale third transition series have practically similar size. This result into even one more important phenomenon. As you go नीचे, the 5S, sorry गलती होगी बेटा भी ठीक कर रहा हूँ, the 7S और 5F होंगे ना, the poor shielding of 4F and 5F, 5F की shielding even poor होगी क्योंकि उसका size बड़ा हो गया, is going to result into 4F and 5F, right, element showing decrease in size, respectively called as lengthenide contraction or actinide contraction का कारण बनेगा. अभी वो भी करते हैं. ठीक, two concept. एक, because of filling of 4F before filling of 5D, the size of second and third transition series becomes almost constant. Second concept, 4F and 5F are having even poor shielding. Therefore, in 4F, as electron 4F1, 4F2, 4F3 are being filled, the size keeps on decreasing. known as soluble lanthanide contraction, and 5F, the actinide contraction. This is going to be a separate concept will become. So the next concept, the elements of second and third have nearly the same radii but are larger than those of the first transition series. The second transition series have larger radii, uska answer bata rahe hum, because of filling of 4D series, which lies further away from the nucleus than 3D, because second and third transition series have similar sizes because of lanthanide contraction. But one word answer, one line answer. The data shows an increase from first to second series of same element, but the radii of third are virtually the same as those of corresponding member of second series. This phenomena is associated with the intervention filling of 4f orbital, which must be filled before the 5D series of the element. The filling of 4f before 5D results in a regular decrease in atomic radii called lanthanide contraction, which essentially compensates for the expected increase in atomic size with increasing atomic number. The net result of lanthanide contraction, फिर single word आ गया ना, is that the second and third series exhibit similar radii and they have very similar physical and chemical properties. Page number 16, अभी वापस आता हूँ, ठीक, पेज नंबर 16. ये देखना, एक मिनट बेटे, ये जिरकोनियम और हैफनियम देखो, सेकंड एंड थर्ड ट्रांजिशन सीरीज 40 and 32, पेज नंबर 16 पे भी वापस आते हैं, कोई बात नहीं. Zirconium and hafnium have been found to have so much of similar properties that they, आपके बचपन का वो कार्टून zirconium atomic number, yep, 40, hafnium atomic number 72, they are almost similar. Do you remember this cartoon, the Dolu and the Bolu? And that is the lanthanide contraction, right? Size is decreasing. Why this happens? Because of 4f orbitals are going to have poor shielding, right? Sizes मत याद करना, तो ऐसे ही रोड लर्निंग हो जाएगी, समय आने पे समझेंगे, राइट? जितना समझ सकते हो समझिए, जितना याद करना पड़ेगा याद करना पड़ेगा. I hope you can understand now. As you move from this to this, as you move from this to this, कौन से नाम आ गए? 4f. 4f में इलेक्ट्रॉन डालने से साइज कम होगा, lanthanide contraction. Therefore, 4D and 5D are going to have approximately, my dear friends, similar. Yes, size is going to happen. Understood the concept? Let's move back where we were originally. चलिए आगे चलते हैं. Ionic radii. For different elements of same oxidation state, it decreases with increase in atomic number. अरे आपको तो coordination complex करवाया गया था, right? So Irving William series याद करो. He's saying iron plus 2, Z26, cobalt plus 2, 27, zinc plus 2, the 28. सबकी ऑक्सीडेशन स्टेट सेम है, तो as Z increases, radius scale size is going to decrease. For same element, the higher the oxidation state, the higher the oxidation state, the smaller will be the radius. Who can forget this? Iron plus 1, iron plus 2. Yes, iron plus 1 में भी जाता है. So, yep, this is going to be the radius decreases. You know, as electrons are being removed, nuclear power, our power. So, वो अंदर की तरफ, nucleus की तरफ electron को खींचता है. The size becomes smaller. Those who are aiming to become scientists, I want to say, maybe computer science में जाना चाहते हो, maybe nuclear science में जाना चाहते हो, the inorganic is your cup of tea. mean it, right? In India particularly, we develop a myopic view. Myopic view, we run after money. So those who are earning money, initially they will be more happy. But if you say the broader perspective of science, then the inorganic is going to be more valid as compared to all. कल को आप एस्ट्रोफिजिसिस्ट बनते हैं, आप किससे खेलोगे? इनऑर्गेनिक. डू यू थिंक ब्लैक होल और ये सब कुछ में आपके पास ऑर्गेनिक आएगी? कल को आप न्यूक्लियर फ्यूजन के लिए, फ्यूजन जो भी हमारे पास, राइट, जो भी न्यूक्लियर फ्यूजन का इंजन हमें बना के देगा वो अमर होगा. सो इनऑर्गेनिक. एनीवे, योर चॉइस. द मेटालिक करेक्टर, all of them are metals due to their low ionization energy and availability of d orbitals. मेटालिक बॉन्डिंग के लिए, मेटल्स के लिए दो मेन कहानियां होती हैं. The strength of metallic bonding increases increase in number of unpaired electron. अरे ये क्या कह रहा है? Just listen, my dear friends. As you keep on adding one electron, the paramagnetism or C number of valence electron increases. The extent of metallic bonding increases. After that, once you start pairing, the extent of metallic bonding decreases. Goes on, decreases. So page number 19, just come back, just wait. So if you see the periodic table, in general, metallic character की बात कर रहा हूँ. These are soft metal. मैग्नीशियम को या कैल्शियम को जोर से दीवार पे मारो या चाकू से काट दो, राइट? सोडियम को डोंट डू इट, डोंट डू इट. आप अपने नाखून से काट सकते हो, डोंट डू इट प्लीज स्ट्रिक्टली, इट इज हैविंग अ corrosive action. तो इधर मैंगनीज, टंगस्टन, मोलिब्डेनम, ये देखो ना, इनमें अनोमलस कॉन्फ़िगरेशन आ गई, D5. So this is going to have highest the melting points. And zinc, cadmium, mercury again becomes very soft. mercury तो बेचारा शर्म से कि उसके पास वैलेंस इलेक्ट्रॉन सारे के सारे पेयर्ड हो गए, वो लिक्विड ही बन गया. जिंक, कैडमियम, आपका जो गोल्ड है, that is not a very hard metal. Don't do it. वहां से मार पड़ेगी. If you're just going to crush a gold bangle like this, इतनी भी जोर लगाने की जरूरत नहीं है, उसका हलवा बन जाएगा. Don't do it. मार बहुत पड़ेगी. माँ से पूछ लेना. तो then you can do it. But otherwise it's a very soft metal. तो गोल्ड की स्ट्रेंथ बढ़ाने के लिए we are going to add impurities into that. तो that is the reason 24 karat gold is very very soft. जिसमें आप डायमंड डालते हो, the diamond वाली ring, that may be even 14 karat, just to give it strength, because it is going to hold the diamond. If the strength is not there, the diamond will fall away. Chromium, molybdenum and tungsten are very hard because of maximum number of unpaired electron, D5. Zinc, cadmium, mercury are very very soft because of no unpaired electron middle. Density. The density increases in a period as well as in the group. You must have just an idea for that. As the added electron are added in the second last section, not in the S. You understand? आपका घर, one room here, अंदर वाली side, I'm saying, which is a core, room. The last room towards the road or towards the पड़ोसी वाला, okay, neighbor's house. So if you are going to encroach upon new area and you are building room and you are letting the guests stay there, then what is happening? Size is increasing. But if you are accommodating the incoming guest here, electrons, in the andar wala room, which is towards the center of your house, what will happen? The mass will increase, size is not increasing, density will increase. This happens here. Down the group, F block आने शुरू हो जाते हैं, right? नीचे सबसे ज्यादा डेंसिटी मिलती है. आप periodic table को ऐसे भी देख सकते हैं. Periodic table is basically, it's a philosophy, it's a prison. You understand? Jail. So the lighter caddy are going to be placed on the top floor. The heaviest caddy, the prisoners, right? They are stored, they are imprisoned in the lower floors or maybe in the basements, ताकि वो छत में hole मत कर दें. That's a philosophy. The increased nuclear charge is partly screened by d electrons, and electrons are strongly attracted towards the nucleus. The decrease in metallic radius coupled with increase in atomic mass क्यों बढ़ा? Protons added. Metallic radius क्यों कम हुआ? Because of poor shielding. So what do you expect? Size छोटा हो रहा है, मेहमान ज्यादा आ रहे हैं, तो crowding is going to increase and the density of these increases. Thus left to right and top to bottom, the density increases. Remember, iridium धरती पे नहीं पाया जाता. This has been found with the help of the meteorites which have struck the earth. And the osmium, right, is having a density of 22.56 gram per cc. So अगर आपको दोनों देते हैं, then definitely the iridium is going to have highest density. But otherwise, because iridium is not found on the earth, so we call it the osmium, which is going to have the highest density. बच्चों ऐसा ही पाया गया है, right? And the density, I do not remember the density. वैसे याद हो भी कैसे सकती थी? The density of scandium 3.43 के आसपास है. 3.43 gram per cc. That is the lightest of all the metals. याद नहीं करनी है, इरिडियम और ऑस्मियम की कर लेना बेटे. तो नीचे जाते हुए डेंसिटी is going to increase. The melting and boiling point, they have high melting and boiling point because of strong metallic bonds. Again, metallic bond is a function of metallic bonding, और metallic bonding किन चीजों का function था? Valence electron and empty d orbital. Presence of one unpaired electron per orbital favors high melting point. Tungsten and ruthenium are having highest melting point, right? D5 आएगा. The boiling point, melting point increases from first to second to third transition. से जैसे जैसे density बढ़ेगी, so compact solid जितने compact होंगे, melting point, boiling point ज्यादा होगा. So नीचे जाते हुए melting point, boiling point increases. That is also, my dear friends, and another reason for the low reactivity of metals on extreme right hand side, lower side, like the gold, the platinum, iridium, mercury. Mercury को छोड़ दीजिए, there is some another reason that is exception, but otherwise mercury भी कोई बहुत ज़्यादा reactive नहीं है. So that is going to be reactive. You can see from the standard electropotential, they do not lose electron easily. See, successive ionization energy of nickel and platinum are provided below. Comment upon stability of +2 and +4. देखो बच्चे, आप एक एक करके देखिए. See here, the +2 तक देखो सिर्फ. यहाँ पे देखो. Nickel और platinum की +2, which is going to require more energy? Platinum. So nickel की +2 easy formed, more formed. Then platinum की +2. Platinum +2 difficult मतलब less formed. You understand? So which is going to be easy? The nickel +2 will be formed easily. Now you see total निकल का और प्लैटिनम का 4 इलेक्ट्रॉन निकालने के लिए. निकल is having ज्यादा, platinum is having lesser ionization. So निकल की +4, प्लैटिनम की +4, प्लैटिनम +4 easy का मतलब कौन सा हुआ? More formed, stable होगा, and that is going to be very difficult होगा. Difficult का क्या मतलब होगा? Less formed, less stable, less formed. So +4 किसकी आसानी से बनेगी? प्लैटिनम की. +2 किसकी आसानी से बनेगी? निकल की. So that is platinum plus 4 and nickel plus 2 is going to be existing. Shall we move ahead, my dear friends? Why these elements show variable oxidation state? The N-1D, you call it penultimate second last shell, and NS have almost similar energy. And here, due to this reason, the N-1D and NS both are called as valence shell, and therefore electron in them are considered to be the valence electrons. So that is, they can show the variable oxidation state. And one thing more important, right? The higher oxidation state are usually found in compound with oxygen and fluorine because of their high electronegativity. These are two wrestlers which can bring out electron from any element, helium, neon, argon को छोड़ के. Oxygen and fluorine practically react with all practically, right? Helium, neon, argon को छोड़ के. And one more point to be noted, osmium and ruthenium shows highest oxidation state in periodic table. That is going to be plus 2. I'm sorry, very sorry, plus 8. अब देखो बेटे, अगर फ्लोरीन मान लीजिए इलेक्ट्रॉन निकालता है, राइट, Fe(F6-3), तो each fluorine can remove one electron. Agreed? आयरन से तो +3 में बैठा. तो अब इधर देखिए, each oxygen, right, can remove 2 electron. Each oxygen, उसके पास 2 इलेक्ट्रॉन शॉर्ट है, उसके पास 1 इलेक्ट्रॉन शॉर्ट है, can remove, yep, how many electron? 2 electron. Therefore, the highest oxidation state, OS, are normally attained with oxygen. This is the Pahalwan, OSO4, ruthenium O4, right? So ये diols बनाने के काम में आता है, osmium tetroxide. Although not very much related here, but you see HClO4. So oxygen is the Pahalwan which can bring out the highest oxidation state, manganese की +7. That is highest in the periodic table, first transition series. You can see dichromate -2. So oxygen has been given this privilege to remove more electron per atom, right, as compared to fluorine. Although the electronegativity किसकी ज़्यादा है? The fluorine की. You should remember. You can ask why the maximum highest oxidation state are brought out by the oxygen. Oxidation state of first row element. ध्यान दीजिएगा, scandium only show +3. Zinc has been found to show only the +2. Whereas silver, copper, +1, +2 में भी जाते हैं. Yes, I'm not joking. Silver also has been found to go into the +2. Notice as the d orbital increases, oxidation state increases. Titanium +4, vanadium +5, chromium +6, manganese highest +7 शो कर रहा है. कौन सा कंपाउंड है? MnO4 नेगेटिव, राइट? क्रोमियम कौन सा कंपाउंड है? Cr2O7 -2. Then they decreasing. So oxidation state shows increase, then they show decrease. That is a trend which has been found. Maximum manganese पे पाया गया है. 3, 4, 5, 6, 7 group manganese, 8, 9, 10, 11, 12. ऐसे ग्रुप्स होते हैं ना, to 12th they are group. Point to be noted. Name a transition element which does not exhibit variable. Scandium and zinc do not show variable oxidation state. Can you understand? Right off. Most of the transition metals are colored in solid. Refer coordination compounds, DD transitions, T2G से EG, EG से T2G. We have discussed color there, right? The color could be explained on the basis of DD transition. But remember, D0 and D10 are going to be white. Zinc +2, D10. Cadmium, oh sorry, +2. D10. Mercury, right? D, zinc, cadmium, mercury. Cuprous all have which D10 configuration? Scandium, D0. Titanium +2, D0. White. Remember, TiO2 is a white pigment, very much unreactive. It has been used, it is being used for providing white color to your medicine. आप सिंपल सी जो क्रोसिन में white color देख रहे हैं because of titanium oxide. Harmless, density कम है ना, तो ये. You people have been taught about this. Mu is under root n, n+2 Bohr magneton, many number of times dipole moment, where n is going to be the number of unpaired electron. So saving time here we did. They act as a catalyst because of unpaired electrons and empty d orbital. They can move from one oxidation state to another. So that is a way iron can go from +1 to +2. First it loses electron, then it returns back. It can be used as a catalyst. Remember surface chemistry, right? I think you people should have a list of catalysts. It has been provided to you in the surface chemistry. Transition metal forms complexes. You remember the coordination chemistry. Because of small size of atoms or ions, they can attract the ligand. High nuclear charge, small size, high oxidation state, availability of d orbital. Although you people know that, but please यहाँ पे जरा time invest करना, because this is going to give you understanding. And understanding is important. Just read it with it. These chapters are more important from your board. Second option पे, this can give you वो marks जो normally हम lose कर जाते हैं. हम इनको easy लेके चलते हैं. Interstitial compounds are formed when smaller atom, hydrogen, boron, carbon, nitrogen, get trapped in the lattices. For example, carbon and steel makes it hard, brittle, soft. Tungsten carbide, chromium boride, these are very, very hard material. So hard that they can drill in a rock, right? So whenever we make tunnels, we are going to have these type of materials placed in the वो जो drilling machine के आगे लगते हैं, which is going to move and which is going to get the stone or the rock out. Since transition metals are quite similar in size, therefore atoms of one metal can substitute atoms of other metal in crystallize forming alloys. These are known as solid state में, solution में, substitutional alloys. Brass, bronze, and more. ऊपर वाले interstitial alloys, where the smaller atom is going to get trapped in the interstitial site. These forms variety of oxide. Remember, oxidation state increases. First, covalent character increases. And as covalent character increases, the acidic character increases. Remember this, right? The oxide of lower oxygen states are basic. Higher one are acidic, with amphoteric coming in the middle. My advice, you follow or you do not follow, entirely your choice. So you people, you have almost 3 months to go for your JEE and NEET exams. You must have a list: basic oxides, acidic oxide, amphoteric oxide, neutral oxide, and keep it as such a place. Maybe wherever you are studying, you just paste a paper there and keep on adding the compounds wherever you find it. And once you are done with that, it will take around 2 months, because you cannot look for what are acidic oxide. देख गया हो सकता है ये दो को मिस भी कर जाए, but once you are moving ahead, then you will be getting knowledge of them, you will be familiar with them धीरे धीरे करके. Then try to arrange in group number 1, 2, 3, 4. That way you will be helped. Question आएगा. Mn2O3 is weakly acidic and mildly basic. It is amphoteric. Knowledge है Mn2O3. MnO2 is amphoteric, and this is going to be acidic, whereas these are going to be, lower one are going to be basic. सुनो, अपने आप में बेटे important है. The scientist, right, from your side must try to learn to read the table. Scandium, titanium and zinc. Configuration याद करने की कोई जरूरत नहीं है. You just remember chromium पे anomalous आती थी, copper पे anomalous आती थी. Stability of half filled and fully filled. एक अंदाजा लेना बेटे, काम आएगा. याद तो कोई कर ही नहीं सकता, याद करेगा तो कोई फायदा नहीं होगा. 326, 473, 515. अरे vanadium has quite high enthalpy of atomization. What is atomization, my dear friends? Atomization is when you are going to heat it, the process of converting from solid to gaseous state, जिसको आप sublimation भी कह सकते हो, is known as enthalpy of atomization. It decreases. कोबाल्ट की भी काफी ज्यादा है, निकल की भी काफी ज्यादा है, तो जिंक बेचारा तो सॉफ्ट बन गया. So that is, it peaks out approximately, right? Iron cobalt पे जाके ये maxima सा दिखा रहा है, and then it decreases. Ionization enthalpy increasing. Trend देखो, increasing. There are exceptions, 1235 and 17. Trend देखो, इनको अंदाजे से टोटल करो. 600, 1200, 1800 and 4200 अप्रोक्सीमेट कर दिया. जिंक को टोटल करो, 2600 and 3800, 7400. Zinc will not lose 3 electrons. Scandium will easily lose 3 electrons. But ionization enthalpy अकेला कुछ नहीं करता. When you are going to remove electron, you have to take solid. पहले आप उसको atomize करोगे. Then you will be hydrating it. So there are going to be many other factors coming into picture. Data is not to be crammed. But yes, I mean, a good scientist should be investing 20 minutes, 30 minutes. TV देखते हुए, but TV पे नहीं, इसको पढ़ना, आराम से देखना. You will discover many things. There's a mother nature. She's creating everything out of that. Metallic radius तो हमने कर ही लिया था. अरे electrode potential, very important thing is going to come. Electrode potential, extremely important, extremely important. You people remember the electrode potential or standard electrode potential. एक ही बात है, standard electrode potential. See, more negative, more positive. इसमें I will be including many cases. Minus, right, 1.63 and minus 0.25. मोर पॉजिटिव का मतलब नंबर लाइन स्केल पे ज्यादा, एंड इसका मतलब लेस है, राइट? I will be putting something like this, say let it be 0.77, and I will be putting 1.97, right? 1.97. More negative, more positive. अब in comparison देखो, if it is more negative, this is going to lose electron easy. ठीक है जी? Let it be metal, metal plus 2. This is going to be more stable. अरे कम होने का मतलब क्या है? Lose electron easily. Refer electrochemistry. And this is let it be m plus 2. Hypothetical example है m plus 4. This is going to be easy. लॉक किया जाएगा प्लीज. एंड मोर का मतलब does not lose electron easy. इसका मतलब out of m and m plus 2 में this is going to be more stable. Out of m plus 2 से m plus 4 पे this is going to be more stable. Now here if you see that plus 2 से plus आने की टेंडेंसी ज्यादा होगी ना, it will be gaining electron easily, it will be losing electron easily. Do you people remember the fundamental video which was taught to you many number of times? More positive का मतलब they are going to be better what? Oxidizing agent, right? Copper plus 2 oxidizing agent, Fehling solution plus 1 plus 2. These are going to be better reducing agent. अभी बताता हूँ. Titanium is going to be better reducing agent. Cobalt is going to be very good oxidizing agent. So no, take it seriously. Extremely important. Discussion is continued. So why I'm discussing it? There must be something. Watch this. No need to copy this table. It is present in every book you have. Every. तो see electrode potential यहाँ पे दे रखे हैं density. Anyway पहले density खत्म कर लेते हैं. That is comparatively easier है ना. The density is 3.43 and so on. It's a factual thing. I can't control it. But left to right, you see the general trend. Density increases. You might find certain exception. I do not have any objection to that. But generally, it will be increasing. 4, 6, 7, 7.21, 7.8, 8.7. It is increasing. Right? Not to be stressed upon. This is something you should be investing time. Right? See, plus 2 से plus 1. इसका मतलब क्या हुआ? Titanium plus 2 and titanium couple. Minus 1.63. And it is a trend. It is decreasing. Titanium is having more negative. Did you notice? Titanium is having more negative. So titanium more negative का मतलब higher oxidation state is going to be stable. And copper is having less negative or more positive or ज़्यादा. So that means इसकी the lower oxidation state is going to be stable. अभी बताता हूँ, चलो अभी बताता हूँ. So this is important. Not all of you will understand, right? They will not be putting time into that. And it is true that all of you take it in a positive way. Do not want to be a good scientist, good surgeon, good engineer. But at least those who want to be, they do that. Maybe somebody of you want, I do not want to go into the engineering, I do not want to go into the medical, and even if I'm going, I will be just living a happy life. So there is nothing harm into that. But those who want to make a niche for themselves, they should study. and I'm going to help you in that. हिंदी हमारी मातृभाषा है तो हमें जरूरत पड़ने पे यूज करनी चाहिए. That way you will be familiar with that, right? So now, in this universe, you cannot decide the outcome, at least in democracy like of thing है ना, कि one people is saying thing वो हमेशा गलत ही होगा, one thing is saying something वो हमेशा right ही होगा. देख बेटे, तो understand what I want to say. Metal is solid. Metal is solid. First stage में what will be required? Heat of atomization. ठीक बच्चों, heat of atomization से this will be converting into gas. Now this gas will be losing electron, one or many. Heat of ionization. You can write I delta के बारे में. You get M plus, मैंने N लिख दिया, that can be 1, 2, 4 कुछ भी हो सकता था, है ना. Now no reaction happens in the gaseous state. It happens in the aqueous state. And this is going to be the hydration. And why I'm writing it in red pen? Because hydration energy is the energy released होती है. That is released होगी. And the पहली वाली है, those are going to be what, my dear friends? Needed होती है. These are needed. So if you say the delta H net, that depends upon heat of atomization plus heat of ionization plus the heat of hydration. You know, if this is more negative, if it is more negative का मतलब process happens easy, right? The process happens easy बच्चों. And if the process happen easy, इसका मतलब क्या होगा? That is net loss of electron क्या होगा? Easy. अब loss of electron easy, तो आपका E naught is going to be more negative. Gurumantar, more negative delta H, the more negative E naught. It will be better what? Reducing agent. The better reducing agent. Or you can say M and M plus में, this is going to be more stable. You understand? This is going to be more stable. Now this is going to be another scenario. This is going to be more positive. This is going to be more positive कह दो, और comparison होगा ना, this is less negative. What does that means? In comparison, this is going to be बच्चों, what is going to happen? This is difficult process. अब difficult process में क्या हो सकता है? Atomization could be more, the ionization energy will be more, hydration will be lesser. It could be anything. But if it is difficult, what does that mean? M and M plus N में से, this is going to be more stable. More stable, it has no tendency to lose electron, or you can say higher will be going to lower. So therefore, these are going to be better. What? Oxidizing agent. Sorry, better oxidizing agent is going to be there. You understand? Very important. Try to understand. I have explained this thing in detail. Invest time there, my dear friends. Invest time there. It is said that who is going to invest time in inorganic chemistry will be gaining access to the best professional colleges like IIT, right? The major 4 IITs, original wale, hai na? And the AIMS. Inorganic chemistry is like that, my dear friends. We just discussed reducing agent get oxidized easily. So higher oxidation state, this is example, more stable than M plus 2, right? So this is going to have the lesser E naught, lesser E naught, lesser delta H. Oxidizing agent get reduced. The lower oxidation state is more stable, more E naught, more delta H. More delta H. For example, I have brought these questions from your syllabus. Why chromium plus 2 is more reducing and Mn3 is oxidizing while both have D4 configuration? देखते हैं. Chromium plus 2 is reducing का मतलब it will get oxidized easily. अब ये भी कराया तो it is reducing का मतलब क्या होगा? Higher oxidation state is more stable. You understand? तो एक सेकंड, चलो अभी ऐसे ही चलते हैं. तो इधर देखिए बेटे. So the higher is more stable. You talk about chromium plus 2, chromium plus 3, crystal field theory. The D3 is taken as what? The half filled. Yes, half filled is nature is going to prefer. So the higher oxidation state is more stable. So its tendency is to lose electron. Lose electron is going to be खुद क्या होगा? Oxidize, and it will be the better reducing agent. Right? The more number of time you see this slide, the more comfortable you are going to see. The Mn plus 3 is oxidizing. अरे वही क्वेश्चन है बच्चों, दो हिस्सों में बांट दिया. पहले इसको डिस्कस किया था, अब इसको डिस्कस कर रहा हूँ. The Mn plus 3 is oxidizing. मैंने डाटा भी दे रखा है उसका, आपको डाटा नहीं याद करने का प्लीज. More stable, oxidizing. अब oxidizing का क्या मतलब होगा? The lower is going to be more stable, है ना? तो see here Mn plus 3, Mn plus 2 में. So this is going to be the lower is more stable, D plus D5. D5 is also going to be half filled, right? That is going to be the more stable. Stability. This is going to be considered as these questions, the most important questions. Not everybody will be able to do that. So this is going to be there. Let's see. I have done my homework, right? I have given you no need to memorize. Titanium की heat of atomization, heat of ionization 1, ionization 2, hydration, सारा डाटा दे रखा है ना? तो stability of half filled, अगले पेज पे जाते हैं. See this dear. This question has been borrowed from your NCERT. पहले एक को पकड़ते हैं, vanadium को पकड़ते हैं. See, vanadium is having less SEP. What he's talking about? The vanadium solid. Say vanadium plus 2 aqueous. Net की बात कर रहा हूँ. The E naught is minus 1.18. Manganese is also similar to that. Right now, focus on this. Here, I have just done the total. Right? This is going to be what? 638. 638 delta H. Positive, right? Positive. Now see, let us see the copper. Copper plus 2 aqueous. E naught is 0.34 volt. उसके लिए the delta H is going to be 923 kilojoule. Obvious dimension, right? Now you were taught अगर delta H is more positive, ज़्यादा E naught is this. That means the lower oxidation state is more stable. वे भी किया ना, number 51 पे वापस आते हैं. See, if E naught is going to be more positive, the lower is going to be more stable. If lower is going to be more stable, we can have different reason. Either heat of atomization is high, or heat of ionization energy is high, or heat of hydration is going to be low. You understand? So that is happening in copper. Copper के लिए 923 is going to be maximum, right? Which is having least, the titanium is having the least 574, and so uska E naught is going to be least. Which is maximum? That is going to be maximum. Hope you understand. Right up. Ab 638 में से 709, right? Which is going to be more. 709 is going to be more. Minus 1.18 say minus 0.76, which is going to be more. I hope you are able to correlate, my dear friends. Right, G? So that is what I'm summarizing. Tendency to be oxidized depends upon atomization, ionization energy. It can be 1 plus 2 plus 3 plus 4. You just take it ionization and hydration. If delta H net is more, it means less tendency to be oxidized. It is reflected by larger value. If delta H is less, it means greater tendency to be oxidized. It is going to be reflected by smaller value. जितनी एनर्जी कम खर्ची देनी पड़ेगी. आप ग्राउंड स्टेट में बैठे हैं, फर्स्ट फ्लोर पे +1, सेकंड फ्लोर पे +2, थर्ड फ्लोर पे +3, फोर्थ फ्लोर पे +4. अगर मैं आपको फर्स्ट फ्लोर पे लेके जाना चाहता हूँ, लेस एनर्जी. ऊपर लेके जाना चाहता हूँ, हायर एनर्जी. That's the point. Right off. So I discussed that. Again, dear friends, see, the E naught value for copper is positive. What could be reason for this? Either atomization is more, ionization energy is more. अरे आ गया. Got it? आ गया उसका. That's the answer. This is the difficult topic here. इसके बाद सारा कुछ बहुत आसान है. Why is the E naught value? I'm giving as a homework. I've explained in best possible way I could think of. I'm giving you as a homework. कुछ कुछ खुद भी करना चाहिए ना. कर लेंगे. ये homework दिया हुआ. Everything has been done to you. So this question will be going as a homework. What is meant by disproportionation of an oxidation state? Give an example. Disproportionation का मतलब one oxidation state changes from 6 to 7 and 6 to 4. You may be asked what is meant by disproportionation. Give 3 examples. So बेटे disproportionation की लिस्ट बनाओ. जितने भी रिएक्शन आपके कोर्स के हैं, नो नीड टू लुक फॉर इट. सिंपली एनसीईआरटी में जहां जहां पे मिले थे, just keep on writing. Even the Cannizzaro reaction will be coming here. This is a homework for you, bete. Read it like a novel. Group trends in D block 5, 6, 7, 8, 9, 10, 11, and this. Please go through that. Right off, just read करिएगा. Next class we will move with important compounds or transition elements. We will be discussing potassium dichromate and we will be discussing KMnO4. उनकी थोड़ी सी ऑक्सीडेशन प्रॉपर्टीज डिस्कस करेंगे, उनका नेचर डिस्कस करेंगे. We will be entering into an important मजेदार the inner transition elements की तरफ चले जाएंगे. इनको याद करवाया जाएगा, तो इनमें एनोमलस कॉन्फ़िगरेशंस दिखाई जाएंगी, राइट. कुछ एक्सेप्शंस बताए जाएंगे. तो we will move ahead with that in the next class. Try to understand this, right? The lanthanide points अगली क्लास में आएगा. The elements, right? So what we do is we stop here, my dear friends, and see you again next class में. इसको आराम से गाते गाते खत्म कर देंगे बेटा. So wait for the next session, my dear friends. You will find it. Good luck. God bless you. Right? Take care. Signing off. Good luck.